Very good evening, everybody. So we are back with a very important topic of class 12 and here class 12 for ISC, and it is there in microeconomics part of class 11 in CBSE. It's even there in ICSE class 10 as well. So the given topic of our today's discussion is the law of diminishing marginal utility, denoted by LDMU, law of diminishing marginal utility. The law was a part of cardinal utility analysis. The first thing to be noted is this law was given by Sir Alfred Marshall, and this law was a part of cardinal utility analysis, which states that utility can be measured in terms of cardinal numbers like 1, 2, 3 and 4. Now, the law of diminishing marginal utility states that when we use or consume more and more of a single commodity, the marginal utility derived from its additional consumption successively goes to zero and turns negative. Now there may be a question in your head that this law is applicable in which particular type of commodities. So we must be very careful in understanding the assumptions behind the law before understanding the law itself. The first assumption tells that the consumer whose utility or whose consumption is being discussed here, that particular consumer is a rational consumer. That is a consumer who thinks about his own self-interest. A consumer who thinks about his own self-interest. Second one is we are using a cardinal utility approach given by Alfred Marshall. Third assumption under consideration is the commodity whose concept is being discussed or whose marginal utility will fall. That commodity is a commodity which can be consumed by dividing into fragments. Like any eatable items, I can have a rasgulla and I can divide the rasgulla into 2 or 3 parts and can consume it as many number of time I want, right? I can consume it in fragments, in small diluted forms, in divisional forms. The fourth assumption to our discussion will be this approach or this law of diminishing marginal utility is applicable only for those commodity which a consumer is continuously consuming. That means the consumption is continuous consumption. That means I'm taking a glass of water now and I'm again taking a glass of water in my evening and again taking a glass of water tomorrow morning. That should not be taking place. If I go on consuming water, it must be a continuous consumption of water. If I go on consuming fuchka, it must be a continuous consumption of fuchka. The consumption is continuous in nature. I guess I'm clear to everybody. Now here we are thinking about and we are going about the law. The law of diminishing marginal utility states, minutely hear it, my dear. The law of diminishing marginal utility states that as we go on consuming more and more unit of a single commodity. Let's take an example of a glass of water. Let us take an example that I came from a football match in the afternoon and I was extremely thirsty. And to quench my thirst, I asked my mom to fetch me a glass of water. When my mom fetched me a glass of water, that single or the first glass of water have given me a huge satisfaction. But it is not the same for the second glass. When my mom saw that I completed the first glass of water and got a huge satisfaction, my mom told me that, boy, you are dehydrating. You need another glass of water to get yourself hydrated. Second glass of water have also given me satisfaction, but not like the first one. The first glass of water has given me an enormous amount of satisfaction, a wonderful amount of satisfaction, but the second glass of water have given me lesser satisfaction in comparison to the first one. So I can calculate the change in my satisfaction. This change in my satisfaction is known as my marginal satisfaction or marginal utility, right? Let us say that the first glass of water has given me 100 utils of satisfaction. So the second glass of water will never provide me 100. It may provide me something less. So the change in the satisfaction, let us say the first one is 100, second one is 80. So what is the change? 20 units is a change. This change in satisfaction continuously decreases, goes to 0 and turns negative. That is the law. So the law states that, sir, when you are taking the first glass of water, the marginal satisfaction derived from the second glass goes on falling. You take again the second, third glass, you take again the fourth glass, your change in satisfaction will continuously fall, sir. It will fall and ultimately reach to a situation when you get to a situation of indifferent. Let us say my father came at the fourth time, and by taking the fourth glass of water, he provided me the fourth glass of water and told me, you have to take the glass of water before you go for a bath. When the fourth glass of water I was taking, I was finding no change in my satisfaction as I have taken glass of water up to here. I have completed all my thirst and I am having excessive amount of water that is actually what required. So what was my change in satisfaction? My change in satisfaction, which is marginal utility, was 0 at that time. Clear? The next is if unfortunately my uncle comes at that particular moment and take up another way to provide me the fifth glass of water, I cannot give him or I cannot tell him no. And unfortunately, by taking the fifth glass of water, I found myself in a tremendously bad situation, in a hilarious situation. And in that situation, I ran to the nearby basin. I started vomiting, and all my amount of water what was inside that have quenched my thirst has already went to vain. It went to what? Negative. My condition was very weak, and I found myself where? In marginal utility to be negative. So I can say, when I've taken the first glass of water, second glass of water, third glass of water, my marginal satisfaction continuously was decreasing. The fourth glass of water has made my marginal satisfaction to be 0, and the next glass of water has made and forced my marginal utility to turn negative. This law goes for every consumer consuming any eatable item continuously at a time. This law is known as the law of diminishing marginal utility. I can show this law of diminishing marginal utility with the help of a diagram here. You can see this is a 2-panel diagram. The first panel diagram is a diagram showing total utility. The second panel diagram is a panel diagram showing marginal utility. Right? Before understanding the diagram, let's now focus on how to calculate the marginal utility. Look, I am having 3 columns. The first column is showing units of consumption Q. The second column is showing its total utility derived from each consumption. Marginal utility also shows marginal satisfaction from the consumption. Right? I was having no output. I was not consuming any output. 0 amount of output I was consuming. So of course, my total utility is also what? 0. I didn't get any satisfaction. Now, the first glass of water. The first glass of water has given me how much? 10 utils of total satisfaction. My second glass of water given me 17 utils of total satisfaction. My entire vessel in my stomach is increasing. Yes or no? My entire vessel of my stomach is increasing. So my total utility was also increasing continuously. It increased and increased up to this. Up to the fifth level of glass or fifth glass of water, my total satisfaction was maximized. It was 22. But unfortunately, the sixth glass of water has given me 19, a lesser total satisfaction, Now, the most important thing to be noted here is the marginal utility calculation. Marginal utility is the change in total utility due to the change in the consumption, delta T by delta Q. Very simply, you can calculate that as the given TU minus the previous TU. What is the given TU? The given TU is 0. Previous to it, you are not having any total utility. That is 0, I can assume it as 0. That is 0 minus 0 will be what? We are not 0, right? But here, in case of marginal or change, I can tell it as undefined. So here I have written here as undefined, a dash. Second, my total satisfaction was 10. The previous was 0. 10 minus 0, 10. 17 minus 10, 7. 21 minus 17, 4. 22 minus 21, 1. And the next, 22 minus 22. Here it is 0. So when I was taking glass of water up to here, I was not having any change in my satisfaction. So my total satisfaction remained what? Unchanged. And as my marginal satisfaction remains unchanged, I can find it as what? Mu as 0. Mu as 0. Then when total utility will be maximum, the marginal utility will always be 0. The last one, my dear, the last one is when unfortunately you find your total satisfaction to be going 19, that is dropping down. I must say 19 minus 22 is how much? Minus 3. So I can say at last my marginal utility or change in satisfaction goes in negative. I started vomiting. Here marginal utility is minus 3. I guess I'm clear. So how many stages? I think so I can show you 3 stages of here. One is the first stage in which you can find the marginal utility to be falling 10, 7, 4 and 1. What is the marginal utility? Marginal utility decreases. The second part is where marginal utility has become what? 0. Here mu is equals to 0. And the last one is mu equals to minus 3. So the last part it is negative. I can depict this entire hypothetical table in this diagram. We can find a 2-panel diagram. The first panel diagram shows a total utility, which is a mountain shaped diagram. You can find total utility increases initially. More and more glass of water has given me a higher and higher amount of total satisfaction. It went to its maximum position and then it started declining, right? Total utility never becomes 0, neither becomes negative. So the entire quadrant will be the positive quadrant, which is out here, which is to be defined here, right? The next down to it, just down to it vertically, I have drawn another panel in which I am measuring marginal utility in this axis and I am measuring quantity consumption in this particular x-axis. I can show you that when TU increases, marginal utility goes on declining. So marginal utility decreases. The second stage tells when TU becomes maximum, I can find marginal utility striking in the axis, that is mu becomes 0. And the third point says when TU goes declining, when TU starts declining but remain positive, mu is found to be here in the negative quadrant. So mu is negative. So we can have complete another question, very important question often asked in board, the relationship between TU and mu. How many relationships do we have? Yes, I can hear you. There are 3 relationships. Number 1, when TU increases, mu decreases. When TU becomes maximum, mu goes 0. When TU goes declining, mu is found to be negative. This is known as the law of diminishing marginal utility, in which the TU and mu relationship is shown in this given diagram. Thank you for today.
Understand.